my numbers are the same. 1.1, 1.4. Total mass is 84 kilograms for me. So M1 plus M2. Isn't that great? We all have different numbers. I like it. All right. So the class chose to put their point of reference right in the center. That works. So from using the center of mass, remember guys, you don't have to follow along, but just be quiet enough that I'm not distracted by you talking while I'm trying to help other people. So you do your own thing, but please don't distract me. So how far is my center of mass? How far is my reference point from my center of mass? Or my center of mass from my reference point? 0. My mass 1 is M1. It is negative 1.1 meters from my center of mass, because I'm taking to the left to be negative. My second mass is M2, and it's positive 1.4 meters from my center, from my reference point, all over my total mass, which I know is 84 kilograms. Hey, I have 2 equations and 2 unknowns. Is it solvable? Of course it is. I just have to do a tiny bit of algebra. Well, because of where you picked the center of mass, and by you I mean your class, I need to, it has to be negative 1.1, or it could be positive 1.1 and negative 1.4, but I need to indicate that I'm going in a different direction to get to those. So, I'm just going to do a little substitution, right? See, I really want, I think they asked for M1, right? Left side of the teeter-totter. So I'd like to keep M1, get rid of M2. So maybe I'll just rearrange my first equation to be M2 equals 84 kilograms minus M1. Then I can substitute that in and have M1 times negative 1.1 meters plus 84 kilograms minus M1 times 1.4 meters, all equals 0. Right? And now all I have to do, I have 1 equation, 1 unknown. Happy days, yeah. Right? It's algebra now. And so solve that for M1. Please choose a different expression. I do find that offensive. Thank you. All right. So we're doing 12. Start with a good equation, right? So it asks about gravitational field strength. So my equation about gravitational field strength. Yep. Oh, sure, you got it. In all the little chaos there. Thank you for reminding me. Good. So I know that R, because I've read my Y, I know that RP goes from the center of the planet out. And let's see, what am I looking for? I'm looking for what altitude above the Earth's surface is the gravitational field strength? G over 4. Well, I know that G is at the Earth's surface. And if I look at my equation sheet and I grab little g, which is the gravitational field strength at the Earth's surface, it's 9.81 newtons per kilogram. So this side is going to be 9.81 newtons per kilogram for me over 4. That's going to equal big G from that same equation sheet, 6.67 times 10 to the negative 11 Newton meters squared per kilogram squared. Let me move this stuff over. Mass of the planet. The planet they're asking about is Earth. And I have mass of the Earth right here, 5.98 times 10 to the 24 kilograms. Most common mistake on these type problems when we have scientific notation is people don't know how to use their calculator and they end up with the wrong order of operations. So make sure you know how to use your calculator or you take precautions against that. I was working with a student yesterday afternoon and they kept doing that over and over again. So I'm looking for this whole distance here, which would be the altitude plus the radius of the planet. So altitude plus the radius of the planet. Planet's Earth. So that's 6.38 times 10 to the 6 meters. And that whole quantity is squared. Yay! All numbers in one variable. What's the magic solution? Algebra! Yay! Huh? I thought I heard a question. Sorry, no. You can treat, I use ALT for altitude. You can just treat that as one variable. You call it H if you wanted or something. So you want to get it so that the altitude is by itself. Is there another one you guys want to do, or should I just do my own algebra? Do my own algebra? Okay. The Earth one. Yeah. All right. So we're going to do the Earth-Moon system. Number 5. Yep. All right. So we're using Earth as our center here. So we're looking for XCM. Earth is our first object. Its center of mass is 0 from the reference point, which is the center of the Earth, plus mass of the Moon, and radius Earth Moon is how far the center of the Moon is away from the center, from our reference point, over mass of the Earth plus mass of the Moon. Nicely, let's see which values are available on our equation sheet. That one, that one, that one, that one, and that one. And the only thing I would caution you to be careful of, they're looking for an answer in kilometers. And our equation sheet, let's see, gives those distances in meters. So I would use meters and then just remember to convert to kilometers before I put my answer. But every value that you need to fill in there, and then it's not even algebra, it's arithmetic, is available on the equation sheet. All right? And again, most common mistake will be people not knowing how to use the exponent key on their calculator and making math mistakes because of that. So be careful of that. Use it or your parentheses well. Did that answer that one for you? Excellent. All right, so I'm going to save that. I'm going to take the last couple of minutes to talk about springs and such.